Hi friends, this is me Abinash and today we'll be solving a very interesting question. So the question is basically longest increasing path in a matrix, and this question was asked by many big tech companies in their coding interview round. So without any further ado, let's quickly look into the problem statement. So in this question basically guys, we are having a matrix of integers, and what we need to find is we need to find the longest increasing sequence. Okay, so let me tell you what exactly it is. So let's say there is a sequence. Okay, that is, let's say, x1, x2 and x3. Okay, so this is, let's say, sequence. Okay, so I can only say that a sequence is a long increasing sequence. So that means it should follow exactly this order. So that means every right element should be strictly greater than the its previous element. So for example, 1, 2 and 3. So I can say that okay, this particular sequence is a increasing sequence. Are you getting me? So like this, but it cannot be greater than or equal to. Okay, it should be strictly greater than. So I hope it is pretty clear. So guys, I have to find the longest such increasing sequence. All right. So there could be many, increasing sequence, but I have to find out the longest one. So what it exactly means, let's say, okay, 9. I'm actually, solving this particular sample example, 994, 668 and 2, 1 and 1. Okay, cool. So now let me actually tell you that okay, just let me, yeah. So let me tell you which are the, you know uh, increasing sequences. So one of the increasing sequence is 1 2, right? Isn't it? So another is if I just include 6. Okay, another is if I just include 9 to it. Okay, another is like if I would simply go on and take this much or take this much. Okay, so all these are the increasing sequences. I could do this, but I cannot actually include this particular part to this particular sequence. Okay, so that is wrong. Are you getting? So all of these are the increasing sequence, but which are the longest increasing sequence? Let me tell you. So the longest increasing is only this much. All right, so there are no other possibility to find out even bigger than this particular result. Okay, so this is why I can say that this is the longest increasing sequence. And what is its length? Its length is 4. So I need to return 4. Okay, so I hope the question is pretty much clear to you. The statement is pretty much clear to you. So now let's look into the solution. Okay, how to actually proceed to solve it. So basically guys, one of the very quick approach, okay, that can come into your mind is, let's say, actually, see what I have told in the beginning is, we have many, increasing sequences, right? So we need to find out the maximum of them. So I can do the same thing. Okay, what we can do is, for let's say for every, let's say for every index, okay, the matrix, if I would find out the increasing sequence for every each and every cell, then if I would find out the maximum of all those number, then I'm done, isn't it? So what I'm saying is, let's say the increasing sequence from here is x. Okay, let's similarly, if I would find out, the increasing sequence from here is x2 and so on and so forth for every each and every cell, and this is, let's say, xn. And what is the answer? So the answer will nothing but maximum of, you know xi, where basically I, let me put it in this way, where I basically start from 1 to n. Okay, are you getting me? So this is the answer, isn't it? So let's implement it and note that. we will do it by just implementing a DFS for each and every cell. All right. So basically, let's say first of all, let's handle some base conditions, then we will move forward. Okay. So guys, one of the very quickest, note then that I would like to share is one of the quickest note I just had forgotten before. So that is basically we are allowed to move in 4 different directions. So that is basically left, right, up and down, but we cannot move to diagonal positions. Okay, so that if that was even possible, right? So let's say if I could even consider 1, 6, and 9 as the sequence. Okay, is the increasing sequence, but that is not possible. Why? Because these are in the diagonal. These are actually present diagonally, so I cannot actually consider them. Okay, cool. So let's handle some base conditions before actually moving to the actual solution. So what if the matrix itself is empty? So if that is the case, there is no such sequences present. So obviously the length of such sequence is 0. Okay. So what if there is only one column and one row? So that means only one element is present. Okay. So if that is the case, I can simply go on and return 1. Okay. Because the number itself is the uh, increasing sequence. Note that each and every number itself is a increasing sequence. Okay, because there are no other element present which I can compare it with. Okay, so for that case I can simply go on and return 1. Okay, I just have to write it 1. I just have to no, no problem. So right now tell me that what is the minimum answer possible. So as I have already told you that uh, you know each and every element itself are themselves are the you know increasing sequences. So I can say that the minimum answer possible is 1. So now let's move further. So what I can do for each and every position, each and every cell, I can simply go on and uh, apply the DFS to find out the the increasing sequence, the length of the increasing sequence from that particular cell, and after all I can simply find out the maximum of all such increasing sequences. Okay, so basically what I'll do is I'll find out the maximum of all such sequences. So let's say the function is LIP. Okay, and as I'm dealing with this particular matrix, so and this particular position ij, so I'll pass that, and along with all of them I'll have to pass, let's say, the total row size is nothing but matrix dot size, and column size is nothing but matrix of 0 dot size. I'm actually considering that that this is a square matrix. Okay, and let's pass the row and column. Why I'm passing that? To only just to verify whether I'm currently in the boundary or not. Okay, I should not move or I should not step into the outside zone. Okay, all right. So right now I just have to pass the previous element as well, previous element as well, because I need to also check that the element currently I am looking at, that should be greater than the previous one. Okay, so as I am actually starting from the beginning, so the previous element is, I can simply pass the negative infinite. Okay, so to minus infinite. Okay, till this point we have just found out our answer, so we can simply go on and return the answer. That's it. So for that I have to write some functions. Let's say the function is get lip, and let me quickly fill the parameters. Then we will start the row and the column and the previous one. Is it all of that? Yeah. So basically, guys, is I'll be writing a recursive function. So we need to first of all handle the best conditions. So guys, what if I am in a cell which is basically invalid one? Okay. So tell me, how can I basically say that whether a cell is an invalid cell or a valid cell? So basically, what I will do is I'll check if I am currently inside the boundary, or that is one possibility of finding whether I'm in an invalid or a valid cell. So that is one possibility. The other possibility is that if the previous character, or I'm sorry, if the previous number is smaller than, if the previous number is basically larger, okay, that should be larger in order to make it invalid. All right, I think it is pretty much clear. So if it is not safe to step into this particular cell which I am looking at, then I have to return back. Okay, so basically I need to find grade. I need to pass grade ij, row and column along with the previous. Okay, okay. So if this is the case, then I need to return 0, because I'm in this function. I'm just finding out the length of the uh, you know increasing sequence. Okay, so the save will be of boolean type, and let's pass the grade right here. Just a second, guys, let me write it down. Yes. All right, and there is one more I just have missed, that is previous. Cool. So what I have to check is if I am currently inside the boundary or not. Okay, that is m, and the previous number should be lesser than the number which is right now, which is I'm currently looking at. So that is nothing but grades current position, current cell. Okay, so all of them has to be passed. Okay, all of this condition has to be passed simultaneously to in order to make the move a valid move. Okay, so if any such discrepancy happen in between, so it will return false, and I'll be right here after that, and this particular condition will be true then, and immediately I'll return 0 just by pruning the path right here. Okay, all right. So as I have just handled one condition, so the answer, minimum answer possible is 1, as I have already told you in the beginning as well. So right here, what I have to do is I have to call 4 times. Okay, because I need to look into the 4 directions, what the 4 possibilities to propagate, or to just write the DFS function. Okay, so basically, guys, let me write down it. So I'm instead of writing 4 different calls, what I have to do is what I can do is I can simply define the position of x and y axis, and I can simply do it in a single call. Okay, so basically let me define the x axis. The x axis will be, okay, if I'll just move upward, then the row is basically decreasing, the column is basically remaining same. If I move to the right, the row is basically remaining same, that means it's 0. Similarly, go down 1 and go left is basically 0. Okay, so that is basically the rows position. And for y axis, which is the column, it should be 0, 1, 0 and -1. Okay, cool. So right here, what is my new x? So which I will be move to the next. Okay. So that is nothing but I plus x of idx, and similarly my y will be j plus y of idx. Okay. And here what I'll do is answer, I'll I'll have to find the maximum of, you know, uh, where I'm currently at. I need to make a DFS call in order to find what is the maximum longest, or I would say the longest increasing sequence from any particular cell. This is what I want, and after finding all the longest increasing sequence from each and every cell, I need to find out the maximum or all those values. So basically, suppose I'm right. Just a second, let me pick my pen so that it would be very, very clear. Suppose I'm currently right here, okay, at 1. Now, let's say I just have make a call to 2, okay. So I see that, okay, this, till this particular point, the sequence is correct, okay. I'm following a right sequence. So as this, current number is basically greater than the previous number, so I can say the sequence which I have made till this point is 1, its length is 1. Okay. Similarly, when from 2 I just have made the call to 6, I can say that the sequence is basically 1 and 2 till this point. 6 is not added till now. So 1 and 2. So the size is basically plus 1. Similarly, when from 6 I just have made the call to 9. So the sequence length is plus 1. So can you see that I am actually adding 1 to 1 for every call? So that is what I'll be doing right here and right now. So that is, I'll add 1 plus I'll simply call to the next possibility. So that is nothing but my create x and y, which are the next possibility, next possible position that I can move to, and similarly the row and the column. Okay, are you getting? And the previous, what is the previous number? So the previous number is nothing but grid of I and j, which was nothing but the parameter which I was having initially. All right, so till this point everything is cool now. So what I have to do right here is I just have to return the answer. Why? Because till this point I have got all the the maximum of all the possible increasing sequence. Okay, so I hope it is pretty much clear to you. Now let's test it out whether it is working or not. So this is the entire code, guys. Okay, so it is accepted, but it will not going to work. Okay, it will not going to work. Let me tell you why. So let's say I am right here, okay, at 9. So from 9, which position I can make my call to? So one of the position is here and one of the position is to here. Okay, that means to 6 and 9. Let's say that this is a valid move. Let's say, just imagine, okay, this is not a valid move, but let's imagine that this is a valid move. Then for this particular position, I mean 0 0, the answer for this is 1. Okay, so when I move right here, okay, when I move right here and again trying to call to 9, actually what I am doing, I am recalculating the value. Okay, but for this, just a second, let me pick my pen. So basically when I make the call to this particular position, again I'm trying to recalculate for this particular position, again I'm trying to repropagate it, right? But it has already been computed before, right? So what I can do is I can simply go on and store the result for each and every cell in a let's say factor or map, what is whatever according to your convenience. And whenever I'm hitting, whenever I'm stepping in into a cell which is which value has already been calculated, already been computed, so what I can do is I can simply use that computed value, okay, in my answer, current answer. I should not recompute it again. Okay, so this is how we can actually optimize it in a very better way. Okay, so how can I do that? Let me tell you. So basically we will simply use the concept of dynamic programming. Let's define the DP, and the DP size will be nothing but the metric size. Okay, and I will fill the DP with -1. Okay, so the -1 will indicate that okay, this particular the answer for this particular cell has not yet found, so we need to compute it. And once the answer for any such particular cell has been found, then and when I actually come to that particular cell, and I see that the answer for that is not -1. So that means what? That means the answer is already available for that particular cell. I need to only use that. So this is what I'm saying. So let me pass the DP right here and just copy this particular portion and let's add it right here. Okay, great. So right here, what I have to do is, let's say after some calls, I see that okay, uh, the value of DP for this particular cell is not -1 anymore. So that means the answer has already been computed. So what I have to do is I have to use that answer instead of recompute for that particular cell again over and over. Okay, and right here as well we have to pass the DP, and after calculating the answer, starting from the cell I comma j, I can simply go on and store the result of I comma j in you know the result for I comma j in DP. Okay, so and I can simply return that. I can simply use that particular value for any other computation further. So guys, this is it. I hope it is pretty much clear to you. Let's test it out. It will be working, I guess. Yeah, it is accepted. Let's submit it to see whether it is actually working or not. And it worked. So guys, this is the solution. I hope it is pretty much clear to you that what is happening. And let me tell you guys, this question is very interesting, very important as well, in terms of coding interviews of any such company, big giant companies. So let me know in the comment section what your opinion is, and let me know that which type of question you want to get solved in next coming videos. So thank you guys, thank you for watching it. Thanks.